Just because something is intelligent doesn't mean it's infallible. Our next speaker will outline how to get the best from artificial intelligence and why connectivity is the key. Next up, the co-founder and CEO of Neo4j will explain why connected data is the key to more accurate, efficient, and credible learning systems, using real-world case studies on everything from space engineering to investigative journalism. Please welcome to the stage the co-founder and CEO of Neo4j, Emil Eifrem.
All right. Fantastic. Man, packed audience. Fantastic to be here. So I thought we'd kick it off a little bit interactive. It's an early morning session. I want to make sure that we're all awake. We're going to start with a little bit of morning gymnastics. No, we're not going to do that. But we'll do a little bit, which is, how many in here consider themselves data practitioners, like a data scientist or data engineer or data analyst? Raise your hand. Oh, probably 15-20%. Awesome. How many in here consider themselves developers? You write code for a living? Maybe a third, something like that. How many in here have heard of graph databases before? More than the union of those. Yes, success. How many in here have used Neo4j? Hand raised. All right, probably 10%, something like that. Sweet. So let's kick things off. My name is Emil Eifrem, and I'm the founder of a company called Neo4j. It's also an open source project and a product, Neo4j, and it's the leading graph database in the world. Before we get into it, I really only have one ground rule, and it's the same ground rule for all my talks, which is that I do not want your undivided attention. Please tweet about this or Facebook message or Snapchat. Choose your social media. But if you tweet, the only thing that I ask about you is that you use the Neo4j hashtag in association, of course, with the Web Summit hashtag, because we monitor that one religiously. Let me know if I'm doing good, if I'm doing bad, and if you have any questions. Cool. So for the people in here, the roughly 50% or so that haven't heard of graph databases, we'll kick this off a little bit with a high-level explanation of what a graph database is, and then we're going to get into the main part of the talk, which is graphs and AI. So my favorite way of explaining graph databases these days is through this. How many in here remembers the Panama Papers? Hand raised. Yeah, probably 60-70%. So this was the biggest news story in the first half of 2016. So the latter half of 2016 gave us the election of Donald Trump and Brexit. So it was dwarfed. 2016 was a fantastic year for us all. But in the first half, the Panama Papers was the biggest story. And it started out very simple. It started out with two journalists at a German newspaper called the Süddeutsche Zeitung, who were contacted by an anonymous person who said that, hey, I have a lot of data from a law firm that specializes in offshore tax accounts. And offshore tax accounts in very tax-friendly jurisdictions, can be used, broadly speaking, for two purposes. It can be used for legal tax planning, but it can also be used for illegal tax evasion. And so we contacted these journalists and said, I have this massive data leak of all their internal documentation. Do you want to have a look? And they, of course, said yes. And what they got was 2.6 terabytes worth of data. And they ran that through a massive pipeline of technologies and ended up with 11.5 million documents. This is emails, this is scanned government forms, and things like that. And they had that data, and they wanted to try to figure out if there were any stories in that data. Right? Of course, now we know that there were a bunch of stories, but if we take a little bit of a step back from the world of data and we just think about investigative journalism is actually all about finding patterns, and it's patterns specifically how things are connected, and not directly connected, because if it's directly connected, people usually know about it. It's the indirectly connected stuff. So here's an example of a pattern. We have a person with a bank account, with an account in a bank. And that is actually the pattern of you. Yes, you. Yeah. And you, and me. This is all of us. This is not a particularly interesting pattern. No offense. You're very interesting. But generally speaking, this is not a very interesting pattern. What becomes a little bit more interesting is if we look at this pattern, we say that this person over here lives at a specific address. At that address, another person lives who also is, who's an officer of a company. That company has an account in an offshore tax jurisdiction, right? All of a sudden, we see that this individual down here is indirectly connected to an offshore tax account. Not directly, but indirectly, right? So in the world of data, we can look at this a little bit more abstractly. These were individuals. We can think of them as person and accounts and banks. In the world of graphs, we call the circles here, we call them nodes. And we call the lines connecting them relationships. With nodes and relationships, and then key value properties that you attach to both the nodes and, very importantly, to the relationships. With that, you can model everything. And what's really amazing is if you have an infrastructure that can work with this type of data in this form, but not just with whatever this 1, 2, 3, 4, 5, 6, 7 nodes, but with 1 million nodes or 11.5 million nodes or 1 billion nodes or 1 trillion nodes. At that point, you can create something really magical. Now, this particular example actually wasn't a hypothetical example. This was the example of this gentleman over here, Sigmundur Gunnlaugsson, who is now the former Prime Minister of Iceland. He actually ended up having to leave his job because he hadn't disclosed the fact that he had previously had this account in an offshore tax haven. Again, not directly, but indirectly through this graph, right? So this is an example of how to use graphs, in particular in the field of investigative journalism. The Panama Papers ended up having massive impact, again, with the biggest story of 2016 until the political stories. Last year, the organization behind it ended up winning the Pulitzer Prize. And exactly a year ago when I was here, actually a year and a day when I was at Web Summit last year, this story had just broken, which is the follow-on story from the Panama Papers, the Paradise Papers, which did not have any Icelandic prime minister, but had Putin in there, had Queen Elizabeth in there, and so on and so forth. A few months earlier this year, NBC used Neo4j to look at a number of Twitter accounts and ended up detecting that there was a lot of Russian troll accounts that swayed key moments in the US election. So all of this data, this is an example of data that you can look at using a graph-shaped form. And it's actually all available. If you go to Neo4j.com, our website, we're open source, so you can just download our product for free. We also have an online sandbox where you can log on and you get a gallery of data sets, including the Panama Papers, including the Paradise Papers, including the Russian Twitter troll. So this is a screenshot from that sandbox, which you just launch. It's a tab in your web browser. It spins up a database in the cloud that you don't have to manage, and then you can just start playing around with this data. So if you think data is interesting, if you're interested in politics and democracy, please use this and go on and save democracy for us. So that's an example of graph usage today, and hopefully you got a little bit of a sense that for the 50% or so of the audience that don't know graph databases, hopefully you have a little bit of a sense of what it is that we can do. So these are very kind of press-oriented, popular examples. So what are people then using graph databases for today? Right? So we have, I would say, there's a handful of use cases that cluster our user base today. Between those 6 use cases, that's probably 2/3 of our user base today. And a very popular one is real-time recommendations. Right? So if you imagine that you're a big retailer, you want to be able to look at purchase patterns. You have stored all your purchase history in a relational database, row by row. Every data looks exactly the same, which is something like customer ID, dollar or euro amount, the product you bought, and maybe a date time, right? That's purchase history. Every row looks exactly the same. It's amazingly well suited for the relational database. And these big retailers have used this technology for, 30, 40 years or something like that. But you can look at exactly the same data in a little bit of a different form, which is, hey, let's draw it out and then look at it along its connections, right? So you have an individual, let's say Emil, right? And I bought these 3 products, and then we have someone else who's also bought those 3 products. And then how about we take the 4th product that this person has bought and recommend that to Emil, because clearly they seem to have some kind of similar purchase patterns, right? So that's called an open triangle recommendation or a collaborative filtering recommendation. And it's a very popular use case for graph databases today. Second one, fraud detection. Fraud detection is today primarily, if you look at the vast majority of fraud detection applications, they analyze and look for correlation and anomalies. And that's great for detecting a lot of different things. What it won't capture is a number of individual transactions that are individually okay, but they're connected in ways that are not okay. So for example, fraud rings. And graph databases are really great for doing that. Third one is network and IT operations. If you're a big telco, your entire business is managing large in-network infrastructure. You want to be able to figure out what happens if that cell tower blows down, what happens if I install a new cell tower over there, if I have a security breach in my big data center, how can that cascade across my entire cloud infrastructure? And for that, it's very useful to be able to build up a graph model, which of course, it fits very well in a graph database. Master data management is customer 360 deployments. How do my customers connect to all my internal systems, which is very popular now in the world of GDPR, but also to external systems like social media. How do you track all that? Knowledge graph is an area that is becoming really, really popular for graph databases, and we'll spend a little bit more time on that later. And then finally, identity and access management. How do I work at let's say a big bank, how do I map from myself to all the various pieces of content and collateral that I have access to? Well, it depends on which groups I belong to, where I sit in the organization, which projects I have been participated in the past, and so on and so forth. How do you manage that entire identity and how it connects to the rest of the organization is a very graphy connected data problem. So those are popular use cases today in the enterprise for graph databases. It turns out that if you look at graph databases, it in many ways isn't as well known as, for example, Hadoop was in the early days of big data, or document databases like MongoDB. But actually, if you look at the popularity of graph databases, it's rising sharply today. This is a site called DB Engines that maps buzz about database projects, right? So it looks at things like LinkedIn skills. It looks at number of tweets. So again, feel free to tweet about this. It looked at a number of job postings, Google searches, a number of signals like that, and it computes a score. And it turns out that graph databases has been the fastest growing category in all of data for several years right now, which I think is pretty extraordinary. This speaks to the power of using connections in data, not just data in isolation. If you look just at our world of graph databases, Neo4j specifically, which is the one where I have the most access to direct data, of course, actually almost 80 of the Fortune 100 are using Neo4j today. And if you look by verticals, it's actually pretty astounding. 20 of the 25 biggest banks in the world, 7 of the 10 biggest retailers, 4 of the biggest telcos in the world. It's pretty astounding what's happened in the past couple of years, really, when this happened. And if I take a little bit of a step back, I've worked in the world of graph databases for 10, 15 years now. This is all I've done. This is my professional life's work. I really see 2 broad waves when graphs started being adopted. The first wave was in the early 2000s, and this is in the consumer web, where we saw a number of companies that came in and they entered a specific market and they said, hey, I'm going to rephrase, I'm going to reorganize and reshape this business around connections in data. So a stark example of this is Google. For the millennials in the room, you can't fathom that there was a world when Google was only 1 out of 10, 15 search engines. But that's actually what it was like in the late 90s. There were, I think, 15 plus search engines in the market when Google entered the space. They all did exactly the same thing. They downloaded the entire web, which I think is an amazing accomplishment, by the way. But they downloaded the entire web, and then when you search for something, they looked inside of each and every document to find, to serve up relevant search hits, right? Now, what Google did, of course, is the famous PageRank algorithm, where they said that, hey, I'm going to do that, but on top of that, I'm going to look at how things are connected, and I'm going to rank based on that. And you know how it works. The more people link to a certain page, the more valuable it is, or the more relevant it's deemed to be, right? And then, of course, it's transitive. So people who then, if that page in turn links to someone else, it has a higher score. This is called Eigenvector Centrality, is the technical term for it in the graph world. But it's much more popular under the name PageRank, right, as invented by Larry Page. So that was the key innovation of Google, right? They said, let's reshape my industry around connections in data. LinkedIn did exactly the same thing. There was a number of different job search sites when LinkedIn came out, but they didn't say, we're going to do exactly that. They said, we're going to do that, plus we're going to map out how people are professionally connected, the graph, right? The same thing with PayPal, actually. That was the key innovation that enabled PayPal, the fact that they had the transactions, how money flowed throughout their system. That was why they were able to do fraud detection, which was actually the key risk with making online payment work in the early 2000s. If you add up these companies that entered their market and reshaped them around connections, you get over $1 trillion worth of market cap in the consumer web. That was the first wave of graph adoption. This right here is the second wave of graph adoption. And this has just been happening for the past 3-4 years, where graphs are being adopted inside the enterprise. So these are not web-first companies. These are not technology-first companies. These are traditional industries that are starting to use connected data to power their businesses. That's the second wave. What we're going to talk about today is what I see as the third wave of graph adoption. And it's starting exactly right now. 2018, I think, we're going to look back to say that was the kind of the key spark moment where graphs started being used in new ways. And of course, that new way is graphs and AI, right? And so the question then is, what is the connection between graphs and AI? This is graphics that I picked up somewhere. I actually don't know exactly where it was, somewhere in my social media feed, which described categories of AI. And I thought it was a really good kind of taxonomy of the various different subfields. But of course, what stands out to me as the graph guy, drinking a lot of my own Kool-Aid when it comes to graphs, was that just the way they visually described all the different fields was as graphs, right? And this is not produced by us. This is someone else who produced this. They just intuitively chose to describe the various subfields of AI using the graph metaphor. So there's something very intimate about graphs and AI, and I think in a nutshell, the way to summarize it is that graphs provide context for AI. And context ends up being a really important thing. I hadn't thought too much about that until a few years ago, but let's take a little bit of a look and explore what context actually is. So this is a picture of me. It's almost as good as my social media picture from 14 years ago that I'm still using. If you look at some data about me, my first name is Emil, my last name is Eifrem, age 40, gender male, right? That's some information about me. Now you're learning something about me. But if I tell you how I relate to the world, I have 2 kids and a baby, actually, as of recently. I work at a company called Neo4j. I'm married to Madeline. I play the piano. I watch The Matrix. I don't know if that's visible. It's a huge coincidence, by the way, that the name of the company was initially Neo, and that's also the main character from the Matrix movies. That's just purely a random thing. So I watched The Matrix. I was born in Sweden, and I actually don't drive a Tesla. This is fake news. I wish I drove a Tesla. I drive a Volvo because Sweden, and also because they're a Neo4j customer. So it's a great car. All of that is what gives me context, right? So this here, now all of a sudden, you understand me way more than just the data that was attached purely to me, right? that context is what makes you understand me, right? So unknown concept, I think as a human being, we learn unknown concepts by relating them to previously known concepts. That's kind of how it works, right? So that's all captured by knowledge graphs, which was a topic that I spent a lot of time on at Web Summit last year, and you can look up that talk, so I'm not going to spend too much time on that today. But then the question is, how can we apply that to machine learning? So today, basically what your machine learning pipelines look like is that you take some kind of data records, you extract them into features, and you use those features to train your machine learning models, right? They look very much like this, like a row in a relational database, right? But you train that with your models, and then those models make predictions in real time, right? But what we actually know about the real world is that the real world doesn't look like the row at the top here. The real world looks like this, right? It's connected, right? So that is actually what's going on in the real world. And it turns out that if you're able to train your machine learning using connections and not just how things are kind of looked at in isolation, you'll be able to predict much more. I can say this with a high degree of confidence because there's been a lot of research about this. This is a guy called Professor Fowler, James Fowler, who did a lot of research. He wrote a book called Connected, where he said he predicted that actually, if I look at not just data about you, but about your graph, your friends and friends of friends, I will have a lot higher degree of predictivity with that data than if I just used data in isolation. He proved that out with election data. He proved that out with non-smoking data. And that, I think, is pretty mind-blowing. If you know everything about me versus knowing nothing about me and just knowing my graph, in the latter example, you're going to be able to predict a lot more. And today, we're not using that in our machine learning, right? So we need to be able to move our machine learning from this discrete feature extraction, right, into connected feature extraction. And by and large, that is what graphs allow you to do with AI. We move from feature extractions in isolation to connected feature extraction, where we can see how things are connected, which ultimately ends up producing much, much better predictions. There are 4 broad areas where graphs touch AI. Last year I talked about knowledge graphs. This year we spent a little bit on connected feature extractions. There are 2 more areas that I think are really, really important. So that's, broadly speaking, how I look at how graphs interact with AI today. I'll leave you with one final thing, which is that the best database in the world, I sometimes ask on stage what the best database in the world is, and people think that I'm kind of looking for positive reinforcement, and they say, Neo4j, I actually think the best database in the world is this one. The human brain. And the human brain is ultimately structured as a graph, neurons connecting to other neurons. So use the best database in the world, use your human brain, but also use a graph database. If you think this is interesting, go to Neo4j.com, download it, it's available for free. Thank you very much.